So you probably covered organic chemistry today in class and you're a little confused. Don't worry, I'm here to help. Topic 10.2 is called functional group chemistry, and it basically explores the different types of reactions that different homologous series go through. So I'm going to divide my video into 4 parts: alkanes, alkenes, alcohols, and substitution and condensation reactions. This video, I'm going to be talking about alkanes and the reactions that alkanes go through. Alkanes have the molecular formula of CnH2n+2, and they go through 2 types of reactions: combustion reactions and substitution reactions. And before we get into the reactions, you need to know that alkanes are low in reactivity. And this is because the carbon-carbon bonds and the carbon-hydrogen bonds are relatively strong. And alkanes are also low in polarity, which makes alkanes very non-reactive, and hence they only go through 2 types of reactions: combustion and substitution reactions. So let's go through combustion reactions first. Basically, what happens in a combustion reaction is alkanes react with oxygen to create carbon dioxide and water in the form of gas, not a liquid. And this is the kind of default of combustion reactions. Any alkane plus oxygen is always going to create CO2 and H2O. But when there's not enough oxygen, I guess it's the same here for alkanes. If there's not enough oxygen, there is a possibility that the products will only consist of CO or just carbon with, H2O coming along with it as well. So the IB wants you to know that these 2 occur when there is not an excess of oxygen. But this is the default when an alkane reacts with excess oxygen to create carbon dioxide and H2O. This is really easy to remember because it's just alkanes plus oxygen is going to be the exact same product as long as the oxygen is in excess. Another thing you might want to remember is that it's exothermic. Obviously, you can remember this because, combustion, something is burning. Obviously, it's going to be exothermic. But the reason behind this is that the bonds in the reactants are much weaker than the bonds in the products. So the CC and CH bonds are weaker than the COO and OH bonds in the products. Let's go to substitution reactions. Basically, what happens in substitution reactions is that there's an alkane with a halogen, and this turns into a substituted alkane and a hydrogen bonded with a halogen. So an example of this would be methane reacting with chlorine in order to create a chloromethane, be like this, and then a hydrogen chloride. So this might be a little confusing, but just remember, any alkane with any element from the halogen group is going to create these 2 products: a substituted alkane, which is basically an alkane with one of the hydrogens replaced as the halogen, and then a hydrogen bonded with one of the halogens. So it's a lot easier when you think of it in this general sense, and then all the examples will kind of make sense. This substitution reaction is a little more important than the combustion reaction because you need to know the mechanism that happens. And basically what a mechanism is it's a breakdown of the steps of a specific reaction. So let's go into the mechanism of the reaction. Basically, the reaction that we're looking at is the exact reaction that we talked about just now. It's between methane and chlorine. And we know that it's going to form a chloromethane and hydrogen chloride. So there are 3 steps to this. There's initiation, propagation, and termination. And technically, you have to remember all these steps. But basically, the way I think of this is that in initiation, it basically breaks down the halogen into 2 free radicals. And free radicals are basically a molecule with a free pair of electrons, or I guess a lone pair that's not bonded with anything. So in the initiation step, basically what happens is this Cl2 splits into 2 individual Cl free radicals. And free radicals, as I said, are just elements with one extra, well, not extra, it's just non-bonding electron. I guess this is a nice place to learn your vocab terms. There's something called heterolytical fission and homolytical fission. The difference between these two is that heterolytical fission, it takes the bonding pair in this, double chlorine and moves it both into just one atom. So then it gives you a positive and a negative ion. So I guess you can remember this as, since it's hetero, and that means more than one. So we can say that there's more than one type of, element or molecule that's being created. Whereas in homolytical fission, the electron pairs get split equally so that it makes two equal molecules. And then there's a propagation step where a free radical basically reacts with another molecule in the reaction to create more free radicals. So what's happening here is basically the chlorine free radical is kind of pulling away a hydrogen to make the hydrogen chloride. And then now this is kind of just left with a free radical methane, kind of, where the hydrogen is kind of pulled off, and then there's an extra, electron that's not paired. So these are all different, possible steps within the propagation step, but just remember that in propagation, free radicals react with something else to create even more free radicals, and that's basically the gist of propagation. Again, these steps you kind of have to remember, but at the same time, it's a little more important to understand what actually happens in propagation. So don't worry too much about the memorization. It will probably come to you as you practice. But just know that propagation creates more free radicals from existing free radicals. In the termination steps, free radicals react with other free radicals to create normal molecules. So it's kind of called termination because it's terminating all the free radicals and actually, arriving at the products that we see here. So termination, just remember, is a free radical reacting with another free radical in order to create just a normal balanced molecule. These, again, have to memorize, but don't worry about it too much. So that's basically the mechanism for a substitution reaction, and this is kind of required for you to remember: initiation, propagation, and termination. And as long as you can describe the steps of what happens in initiation, propagation, and termination, you should be fine with the mechanism regarding alkanes. So that's about it for alkanes. Hopefully that helped. Alkanes go through combustion and substitution reactions. Combustion is really simple. It's just alkanes reacting with oxygens in order to create carbon dioxide and H2O. Substitution reactions basically happen between alkanes and halogens. They create a specific substituted alkane and hydrogen bonded with a halogen, basically. And there's 3 steps that you need to remember to this reaction, which is initiation, propagation, and termination. If you have any questions, you can leave it in the comments below. I will be answering every single one of them. But yeah, hopefully that helped. I'll see you in the next video.